Complete combustion and incomplete combustion. So as we discussed last day, the complete combustion means the combustion that happens and the fuel will be completely converted to the other components. So basically it will react with oxygen gas and it will emit H2O vapor or water vapor and carbon dioxide here. So please read this: complete combustion occurs when an adequate oxygen gas, right? Adequate oxygen gas is supplied for the combustion. So this is another factor, right? When oxygen gas is not enough, then also there will be incomplete combustion. Oxygen madina, it combustion partially වෙන්නේ. මොකද ඔක්සිජන් නැහැ නේ. දහනයට ඕන ඔක්සිජන් නැති වෙනකොට සමහර දහනේ නවතින්න ඉඩ තියෙනවා. එහෙමත් නැත්නම් අඩුවෙන් තියෙනවා නම් අර්ධ දහනයක් වෙන්න ඉඩ තියෙනවා. You know the fuels contains elements of carbon and hydrogen that I said. So fuel, like these are hydrocarbons, basically fuel. You have hydrogen and carbon molecules, but as a combination, right? Then, so on complete combustion, carbon gives carbon dioxide. I said that in the complete combustion, all the carbon molecules will react with oxygen molecules and produce carbon dioxide completely. That means carbon is 100% combust. Carbon තියෙනවා 100%. දහනය වුණොත් carbon dioxide හැදෙන්නම ඕන. Right? So that produce carbon dioxide and hydrogen with oxygen, it will produce H2O or water vapor. Hydrogen with oxygen will produce H2O or water vapor. Right? More heat, and also there will be more heat. And we can just observe the candle flame to understand the combustion level. Right? This is like invisible or the barely visible outer layer we call outer zone, and luminous zone is where you can see the yellow color flame, and non-luminous zone basically, so it has no luminosity, is basically in the black color, right? And blue zone, this is where the full combustion happens. Actually luminous zone is basically, it's not full combustion, it is partial combustion. So where the flame, like where the temperature is high, is it in outer zone, luminous zone, non-luminous zone, or blue zone? So what do you think? Yes. In which layer the heat is high? So if there is a full combustion here, heat produced by the flame. Blue zone? Sorry, blue zone. Yeah, in the blue zone, because there is complete combustion, right? Because unburned here. So combustion, even combustion is incomplete, carbon monoxide and unburned carbon particles, not just the carbon monoxide, it's not carbon dioxide, carbon with one oxygen molecule, carbon monoxide. Mono means one. Carbon dioxide means two oxygen molecules. Carbon dioxide means carbon and two oxygen. Carbon monoxide or monoxide is carbon and one oxygen. Okay, that is the simplest way, right? When carbon monoxide and unburned carbon monoxide unburned carbon, burn වෙච්ච නැති carbon තියෙනකොට තමයි දැල්ලට පාටක් එන්නේ, right? So this is in carbon monoxide and unburned carbon particles are produced in addition to the carbon dioxide and water. In incomplete combustion, combustion, the heat produced is relatively lower than the complete combustion. In the complete combustion, only carbon dioxide and water. Okay, let's see. When a candle is lit, solid wax here, you can see in this, actually the candles are made of wax, no, solid wax, that will be converted into liquid wax. Actually liquid wax move up and it will vaporize. Then this vapor, basically this liquid wax vapor, will react with oxygen and produce heat and light, giving rise to the flame of the candle. And so let's say inner zone is non-luminous here. This is inner zone, it's non-luminous. It contains wax vapor. Wax vapor means like wax as gas, right? The temperature is low relative to the other zone. And outer zone is non-luminous zone and luminous zone. Outer also there is a non-luminous and luminous zone. In the unburned carbon particles are present in the zone, right? So when the unburned carbon particles are present in the zone, becomes incandescents emitting yellow light. So this is actually because of the carbon monoxide and unburned carbon. දහනය නොවිච්ච කාබන් සහ කාබන් මොනොක්සයිඩ් තියෙන හින්දා තමයි මේ කහ පාටක් තියෙන්නේ. සමහර වෙලාවට ඔයගොල්ලෝ දැකලා ඇති when you are using the gas cooker, sometimes you have yellow light. Sometimes that's a blue light. When blue light is present in the gas cooker, the heat is very, very high and burning happens fully. Normally gas cooker will have gas cookers වල තියෙන්නේ normally මොනවද blue light එක තමයි වැඩිපුර තියෙන්නේ. Because in liquid, like this is LPG, right? In LPG, the complete combustion is high, but this wax-based system or this oil-based systems, it is not complete combustion. That is why we cannot use this as alternative to gas, because the flame has this unburned carbon will be after some time it will be sedimented. It will be there in the in this like cooking elements, like we are using the baskets, whatever, that trays and all, and these things that we are using. So normally when this candle wax is there, the unburned carbon will be in the surface after some time. So you can see that as black color surface. Candle light එක අල්ලලා බලනකො භාජනයකට මොන හරි කන්ටේනර් එකකට candle light එක අල්ලලා බලුවොත් ටිකක් වෙලා අල්ලගෙන ඉඳිද්දි ඔය භාජනයට කළු පාටට බැඳෙනවා. මොනවද මේ කළු පාටට තියෙන්නේ? What is this black color thing? Yes, is it wax or something? So what is there? That is basically unburned carbon. ඒ burn වෙච්ච නැති carbon තමයි. carbon කොහොමත් මේ කළු පාටයිනේ පුතේ. එතකොට ඔය burn වුණේ නැති carbon තමයි බැඳෙන්නේ. දැලි විදිහට බැඳෙන්නේ භාජනයට. ඉතින් දැන් මේ candle light වලින් මේ වගේ නැත්තම් oil base ඒ වගේ ඒවා දහනය කරොත් ගොඩක් වෙලාවට යට කළු පාට දැන් පහන් පත්තු කරන තැන් වලත් ඔය තියෙන කළු පාට දැල්ලක් තියෙනවා. There is this unburned carbon will be there in the surface. එතකොට සාමාන්‍යයෙන් gas cooker එකේ කළු පාට දැල්ලක් බැඳෙනවද? Normally the අඩුයිද? අඩුයිනේ. It's very it's very light. යාන්තම්. ඒකට හේතුව මොකද්ද? unburned carbon අඩුයි. ඒ කියන්නේ මේක පූර්ණ දහනයක් වෙනවා. පූර්ණ දහනයකට ළඟින් යනවා. පූර්ණ දහනයක් නෙවෙයි 100%ක්ම වෙන්නේ නැහැ කිසිම දෙයක්. 99% that is basically 99% the combustion has happened. It is not incomplete. You can say it's more closer to complete combustion. That is why you cannot see any carbon in the surface of the container after cooking. Right. So remember these examples, right? Gas එකේ බැඳෙන්නේ නැහැ දැලි. එයි මේකේ බැඳෙන්නේ වහන්න පුළුවන්. gas එකේ බැඳෙන්නේ නැහැ. හැබැයි ලාම්පුවක දැලි බැඳෙන්නේ නැහැ. දැලි කියන්නේ මොනවද? මේ unburned carbon. Unburned carbon will be there in the surface as a black color solid layer. Okay, then here non-luminous zone, you have the candle wax, the vapor, and in the luminous zone the burning happen. Burning happen means will react with the oxygen, but there are unburned particles of the carbon. That is why the yellow color is there, the outer layer, right? So then outer to the luminous zone, another zone which appears in blue color at the base of the flame but is hardly visible. This is known as outer zone, invisible zone, and has the highest temperature, right? So this is basically invisible and it has highest temperature. But what about the blue zone then? Isn't it having that highest temperature?
It has highest temperature.
Which? Blue color or invisible?
Blue zone.
Then what about the like this outer zone, the barely invisible outer zone? That's 2, right? That's 2, right? If you consider that's 2 having that. Okay. So here you can see. So here, so normally we call the highest temperature at the end, this layer. it has the highest temperature. But full burning, like this blue zone here, actually inner zone, so we can see the temperature. Let me show this quickly. Right, different temperatures. So there is the measured one. Okay, there is a measured one. I can show you the image, I think. In candle frame. So in the image, you can see there are temperature. Okay, here. Right. This will give you better idea. Okay. So I think this is better. Right. You can see how the temperature varies. Right. Here the outer zone, the invisible zone has the highest temperature. Right. Then blue zone එක කියන්නේ මෙන්න මෙතන ඇතුලේ තියෙන මේ colorless එක තමයි මෙතන මෙයාලා අරන් තියෙන්නේ මේක dark zone එක මේ තියෙන්නේ මේක මම හිතන හොඳට පේනවා. Right, dear luminous zone, then you can see the outer layer is like 1400 Celsius, and here so you can see dark zone is having 1000 temperature, and the blue zone is here. So this is what the blue zone, make මැද්දේ තියෙන blue zone එක නෙවෙයි black dark zone එක මේ තියෙන්නේ this blue zone, it's having the lowest temperature there. But that right, but that indicate right here this is another image. You see, so this is in kelvins. This is in kelvins. Can you see this here? The dark zone is having here I cannot see the figure 1800. Here it says this zone is around 2400 kelvins. Right, it depends, right? It depends because there are different layers here. Here you can see, so blue outer flame, so please understand that this is invisible, right? This is not the inner zone, this is blue outer zone because this is barely invisible. So that is why I said that it depends. If somebody is taking this black zone, it will misinterpret because there will be the least temperature. But in your book, I don't know whether they have taken this one. සමහර කට්ටිය මේ black එක blue කියලා ගන්නවා. මේ මෙතන දැන් ඔයාලට ඔක පොඩි margin එකක් තියෙන්නේ. මෙතන පේන්නේ නැහැනේ මට මේ image එකේ පේනවා චූට්ටක් බලමු අපි මේක ලොකු කරලා. Let's make right. Okay. Oh no, this one. Right. Hi. මේ මෙතන තියෙන ඔයාලට පේනවාද මේ visible invisible layer එකක් තියෙනවා එළියේ. This is what this blue outer zone means. It's invisible. It's like invisible zone. This has highest temperature. හැබැයි මේ ඇතුළට තියෙන blue black එකක්. This has the lowest temperature. Right? Therefore, be careful, right? When you're telling blue zone having like lowest temperature, be careful because this light blue outer zone is having the highest temperature. That is also light blue. You can see here. They just display this using light blue, but this dark blue or black color thing, it's having the lowest temperature. That is inside. අර තියෙන තැන අනුව තමයි ගන්නවා. මේ outer layer එකේ තියෙන thin layer එකේ තමයි වැඩිම. හැබැයි මේ inner එකේ තියෙන dark blue black වගේ තියෙන තැන ඒක අඩුම. Understand this carefully, otherwise you will misunderstand, right? Blue is having the highest temperature, that is true. Right? Blue is having the highest temperature, but when in some images they display this as blue zone, but it is not about this blue zone, it is about the outer layer of blue or invisible zone. Normally this blue like thing is black. සාමාන්‍යයෙන් අපිට මේක පේන්නේ black. Okay, you can see this is a correct image. Blue outer frame is having the highest temperature. This is burning week, or the burning that is very closer to the this burning week.
Okay, sir.
Okay, I hope you understood that. Anyway, so next is yellow zone, right? Next is yellow zone. Then if you identify as this, then it's easy. Which zone has the highest temperature? Zone 5 or zone 4? Zone 1 is surely having the lowest temperature. Zone 1 is here. Zone 1, zone 3 having lowest temperature, but zone 5 is having the highest temperature. Zone 5 is invisible, right? It's visible, invisible. La nil patak tama තියෙන හැබැයි පේන්නේ නැති තරම් දැල්ල පේන්නේ නැති තරම්. පේන්නේ නැති තරම් කියන හේතුව තමයි ඒකේ මුකුත් නැහැ අංශු. ඒ කියන්නේ carbon, you cannot see any carbon or carbon monoxide there. That's the reason. So let's move back. Sometimes you might misunderstand because of this blue zone. So what I'm referring to is this invisible blue zone, that is, but in here they have given blue zone something else, right?
Okay.
Not misunderstand. Here this dark blue zone, I think they are referring to this zone. This dark blue zone, you can see it's having here also in the Bunsen flame. Bunsen flame is using some other fuel. It's not using the candle wax, so it is more powerful than the candle flame. The color of the Bunsen flame changes with the amount of oxygen supplied to the combustion. When the oxygen supply decreases, flame turns yellow. Right? When oxygen supply is really low, it turns yellow. And when oxygen supply is high, it turns blue. Right? By observing the flame, okay. So again, the same thing. The invisible zone is having the highest temperature. Then light blue, dark blue, and you can see non-luminous. These zones are having low temperature compared to the invisible or very light blue zone. Very light blue zone, it is basically invisible. That is where the complete combustion occurs. Right. So now we have come to the last topic, that is tarnishing of metal. Okay. Why metal tarnish? So what are the factors affecting that? ඇයි මේ ලෝහ විනාශ වෙන්නේ? මේ ලෝහ විනාශ වෙන්න හේතු මොනවද? Yes.
Because of rusting.
Rusting is one thing. Malamadi, rusting is one thing. Actually, it reacts with, right? So basically, it reacts with the gas in the air. But it needs some factors, not just the air. Air vitarak tibbata madi, it needs some other factors. Let's see this using some experiment. Okay, here in this experiment, so please refer to this experiment. Here in this experiment, we are using 3 test tubes. So actually, there is a coconut oil layer here and here, and boiled water is placed in this one and this one. Coconut oil, boiled water, and here boiled water, here cold water. What's the difference between the boiled water and cold water? Why we are using 2 kinds of water there? Why boiled water and why cold water? Any reason? What do you think? Why are we using both boiled water? Don't look at the note. Without looking at the note, can you tell me? Yes. What will happen when you boil water? Yes. What will happen when you boil water? Okay, there are gases. There are gases dissolved in the water. When you boil that, these gases will move out. That is the idea, right? මේ වතුරේ දියවිච්ච වායු තියෙනවා. ඔක්සිජන් එහෙම දිය වෙලා තියෙනවා. එතකොට රත් කරාම හොඳට බොයිල් කරාම මේ ජල වතුර මේ ගෑස් ටික මේකෙන් අයින් වෙලා යනවා. හරි මේකෙන් අයින් වෙලා යනවා. ඒක තමයි reason එක. Right? That is the reason why we are boiling water, because the gas dissolved in this water will be removed when you boil. But when you keep the cool water, there is an amount of gas in there. So why there's a coconut oil layer? To ensure what? Yes. එතකොට අලුත් gas එන්නේ නැහැ පුතේ මේකේ. Right, gas. So because when water is there is a higher tendency. Right? When water is there's a higher tendency to right here. So let me share this image to your group. Found very good image with explanation. I'm sharing that to your WhatsApp group. I'll show this later. Right? Wait, don't look at that. I'll explain that later. Just look into this. So why there's a coconut oil? Because when water is kept in the air environment, so there's a tendency to oxygen and other gases to come and dissolve in the water. මේක වාතයට නිරාවරණය වෙලා තියෙද්දි මේ වතුරත් එක්ක නිතර මේ වායුන් දිය වෙන්න පුළුවන්. ඒ හින්දා තමයි මෙතනින් සීල් කොකනට් ඔයිල් එකක් දාලා සීල් කරන්නේ. කොකනට් ඔයිල් හරහා එන්නේ නැහැ gas. This is seal. Okay, what do you expect after keeping this setup for some time? What do you expect? Clean iron nails are there. So can we see rusting? And so which will rust, which will not? What do you think? Yes. Hello.
A will rust.
A will rust. Not. BC, which will get more rusting.
C will not rust, sir.
B will not. Okay.
C will more rust, sir.
Yes, in C you can see more rusting. Reason is in the cold water there is amount of dissolved oxygen. So this iron nail and it will react with the oxygen, and it is also open to the environment. So it will take oxygen from the environment as well, because when the amount the oxygen ගන්න මොකද වෙන්නේ? වතුරේ oxygen අඩු වෙනවා. Right? The iron nail is, and that is basically it's reacting with oxygen. So the amount of oxygen will be less in the water. Then what will happen? It will take oxygen from the water environment. මෙයාට oxygen ඕන වෙන්න ferric oxide නේ හැදෙන්නේ. මේ ferric oxide කියන්නේ මේ මලකඩ හැදෙන්න oxygen අඩු වෙනවා. oxygen අඩු වෙනකොට එයා නිකන් ඉන්නේ. එළියෙන් තව ගන්නවා. මේක තියෙනවනේ. Sorry. So it will take oxygen from the outside environment. Right? So that will happen. Then make a rusting වැඩි. මොකද මෙයාට oxygen වැඩිපුර හම්බ වෙන හින්දා. And there is amount. We cancel this. I think I'm getting too much. Of course, let me cancel it first. Okay, here you can see some amount of water. This less rusting compared to this one. Here you can see more rusting, but here you can see less rusting. Why there is less amount of rust? Because this will react with the water here. The amount of water, it will react, and but after that, due to the coconut oil seal, new oxygen molecules will not arrive. So amount of ferric oxide is less than this one, and this will get more ferric oxide, but this will get less. But here the dissolved oxygen is removed by boiling, so the amount of oxygen is very less. So you can see actually zero or no rust, a minimum amount of rust there. That's the thing. Right, I think you got that. Okay. This is another setup. right? Now this will prove that rustin needs oxygen. The making up improve in මොකද්ද? rustin වලට oxygen ඕන කියන එක තමයි මෙතන improving. The second one, in the second one we are using this. In the second example we are using this. You can see in the second example you can see this here. Wax cork stopper iron nails are used here. Why there's a wax wax cork? Because to seal this properly, the wax one is used to seal this properly, right? This is used for sealing purpose. And then calcium chloride crystals are also placed here. Calcium chloride crystals are also placed here. Why the calcium chloride crystals? Because right, when there is like calcium chloride, so what's the reason for adding calcium chloride there? මේ iron nail දෙපැත්තටම ගහලා තියෙන පුතේ පැත්ත ප්‍රශ්නයක් නෑ කියන්නේ. නැත්නම් මේ ලස්සනට නෙවෙයි. ඒ කියන්නේ උඩ පැත්ත මල බැඳෙනවද යට පැත්ත මල බැඳෙනවද කියලා එහෙම දෙයක් නෑ කියලා පෙන්නන්න තමයි මේ දෙපැත්තටම ගහලා තියෙන්නේ. The iron nails are placed in this way because to show that the side is not relevant. Okay. Then why calcium chloride crystals? What's the reason?
To absorb water vapor.
Yes. So when calcium chloride crystals are there, that will absorb water. And what is not there then? Here you have enough gas, oxygen is there, but now another factor is missing. For rusting process, yes, we need H2O2. For rusting process, we need H2O2. Actually here, calcium chloride crystals absorb moisture in the air in the boiling. Placing wax around the stopper makes air tight and preserve entry of moisture. So the moisture from the environment will not come inside the tip. So when you see the experiment, after some time there will be no effect of rusting. Then අපි දෙකක් prove කරා. First thing is for rusting we need oxygen. Oxygen නැත්නම් මල බැඳෙන්නේ නැහැ. The second thing is for rusting, to stop rusting, we can remove the moisture. එතමනේ නැත්නම් ඒත් මල බැඳෙන්නේ නැහැ. ඒතර ඔය දෙකම අත්‍යවශ්‍ය සාධක. Okay, so this shows this is very nice experiment, right? Here moist cotton wool and moist cotton wool, same amount of moist cotton wool මොන තෙතමනේ දීලා තියෙනවා, and iron fillings is there and it is sealed. හරි, දැන් මේකේ තියෙනවා moisture cotton wool, මේකේ iron seal තියෙනවා. ටික දවසක් මේක තියන්න ඕනේ. How to keep this for some time. Now after that you can see this water is rising up. Wow, what is that? මේක ටික වෙලා මේක කාලයක් තිබ්බම දවස් දෙකක් විතර තිබ්බම මට පේනවා මේ වතුර උඩට යනවා. හරියට මේක වතුර උඩට යන්නේ නිකන් 120ක් විතර උඩට යනවා. 20% will move up. Closer to 20% will move up. What do you think? What is the reason?
It gets oxygen from air.
Yes, it gets oxygen from air for a rusting purpose. හරි, මල බැඳීමට oxygen අවශ්‍ය වෙන oxygen ටික ගන්නවා. එතකොට වතුර උඩට යන්නේ. This is moving up. The oxygen ගත්තට කමක් නැහැ නේද? වතුර උඩට යන්න ඕනේ නැහැ නේද? Why water is moving up? Why water levels?
ඒයිද පිරෙන්න වතුර උඩට යනවා.
There will be a vacuum, right? Vacuum means like, so what is the percentage of oxygen in air? වාතයේ oxygen ප්‍රතිශතය කොච්චරද සාමාන්‍ය? Percentage of oxygen in air.
21%.
Yes, closer to 21%, right? Closer to 21%. ඉතින් ඒ හින්දා මොකද වෙන්නේ? මේ මල බැඳීමට ඔක්සිජන් අවශ්‍ය හින්දා ඔක්සිජන් ටික ගන්නකොට ඔක්සිජන් මදි වෙනවා. ඔක්සිජන් මදි වෙනකොට මෙතන වැක්කියුම් එකක්, මෙතන අඩු පීඩනයක් ඇති වෙනවා. So pressure will be less. තිබ්බ වගේ 120කින් 21කින් වද වෙන්නේ. මේ පද්ධතිය ඇතුළත තියෙන දේවල් ටික බැලන්ස් වෙන්න එපා. මෙතන තියෙන ඔක්සිජන් ටික අඩු වෙලා ඒ ඔක්සිජන් මෙතනට යනවා. ඉතින් එතනට ගියාම then amount of oxygen in the gas will be removed. So here you have no oxygen. Therefore, in order to fill that gap, fill that low pressure, 21% closer to 21% of the water level will move up. But here you cannot see any reaction as as there are no reactions, this remain as it is. Okay, that is the rusting process. Okay, how can we stop the rusting process? So one thing is you can remove the oxygen, but unfortunately then we cannot keep these metals in the real world, in the outside world. Oxygen we cannot keep that in the environment. The next thing is you can remove the moisture. We can remove the moisture, but the thing is, again, in the real environment, moisture will be more or less there. Therefore, the third thing is we can stop the contact. The third thing is we can stop the contact. So we are doing two things to stop the contact. So one is we are painting with tin. The other one is we are painting with zinc. So if you are painting with zinc, it is called galvanizing. Right? Painting with zinc is called galvanizing. Painting with tin is also there. Tin කියන ලෝකය ආලෝක කරනවා. නැත්නම් zinc ආලෝක කරනවා. Zinc උත් ඒ වගේ මේවා වෙන්නේ නැහැ. ඒක galvanize කරනවා කියලා තමයි එකට කියන්නේ. Here a galvanized bucket. Right? Galvanized bucket is basically during galvanizing zinc metal is applied. Right? Zinc තමයි මේකේ වටේට ගන්න. During the galvanizing process, zinc metal is. And another thing is painting. Very simple thing. පාට ගෑවත් හරි නේද? පාට ගන්න පුළුවන්. galvanize කරලා zinc ගන්න පුළුවන්. එහෙම නැත්නම් tin ගන්න පුළුවන්. tin කියන metal එක ගන්න පුළුවන්. That is the third thing. Okay. Here tin metal. Okay. The last thing is, am I too fast? Right? Okay. Last thing is neutralization. Neutralization means we have like I think you can remember we learn about acids and bases in grade 6 as well as grade 7. So acids we can just test this using litmus paper. Acids none like water, pure water is having pH 7, but acids are having less pH and more pH in bases. Right, we can also use phenolphthalein to see this. Here hydrochloric acid is basically having less pH level. We can use pH papers to test that. Then sodium hydroxide is a base. Sodium chloride is neither acid or base. Right, by using a pH paper we can observe that. And so phenolphthalein is like an indicator, right? So phenolphthalein is an indicator. It turns into different color based on that. Right? Basically, when it is pH 7 or neither acid or no base, so the phenolphthalein will not change color. Right? But when solution B, when there is a base, right? So then you can see phenolphthalein pink color. The phenolphthalein color will be pink. Pink color එකට හැලෙනවා base එකක් නම්. Sodium hydroxide, or you can use basically soap solution. So it will turn the phenolphthalein into pink color. Then the third one is solution C. Then that will, like, again, pH will be less. The color, pH will be less. Then again, phenolphthalein will not show color change when it is here, phenolphthalein no color change in C, because C is neither acid nor base. Phenolphthalein will change the color here to pink because it is base. Phenolphthalein will not change the color when it is acid. Acid එකේදී phenolphthalein color වෙනස් වෙන්නේ නැහැ. Base එකේදී වෙනස් වෙනවා pink වලට. Acid නොවන base නොවන වෙලාවටත් color වෙනස් වෙන්නේ නැහැ. And can you remember the litmus reaction to this? Litmus papers අහලා තියෙනවනේ. දැන් නිල් litmus තියෙනවා, රතු litmus තියෙනවා, red litmus, blue litmus. So what about the litmus color in solution A? Right? How acid is indicated? Yes, how acid is indicated?
In A solution, it converts into red.
Yes, you have to use blue litmus. Blue litmus will be converted to red. Red litmus will not change the color. Blue litmus will change color to the red. So then this one, base.
Not change.
When it is base,
Not change, sir.
blue litmus will not change. Then
Red litmus.
red litmus will change the color to blue.
Blue litmus.
Okay, what about C?
C does not change, sir.
No color change, and it will remain as it is, right? It is also given right here. I see that blue litmus into red in solution A. Here, red litmus into blue in solution B. Blue litmus not change color. C, no color change. No color change for phenolphthalein, and pH will be 7. Here pH greater than 7 because it is a base. Pink color phenolphthalein, and red litmus to blue color. Right here, blue litmus to red color. Then no color change for phenolphthalein, and then here pH will show less than 7. Right. When we are using the acid and base, when we react them in proper proportions, so it will neutralize. Right. You can observe that using the same setup even. So if you put sodium hydroxide to hydrochloric solution, so basically, you know, oh, let's do some other way. Let's put phenolphthalein. Phenolphthalein will be in the pink color in this solution. Then you can slowly add hydrochloric solution. At one point, the color will be disappeared. The reason is it will be neutralized. Again, sodium hydroxide වලදී phenolphthalein රොස පාට තියෙනවා. අපි හිමීට මේකට hydrochloric දාගෙන යද්දී එක level එකකට පස්සේ hydrochloric වලින් sodium hydroxide මේ දෙක ප්‍රතික්‍රියා කළා මේක neutralize වෙලා වතුර solution එක acid උත් නෙමෙයි base උත් නෙමෙයි එතනට. එතකොට අර color එක නැති වෙලා යනවා. That is one thing, and you can test that same situation, same place, same thing using this blue litmus and red litmus. It will not show any color change at that point. Then we can say it is pH 7. That is what the neutralization reaction is. Is it there in the book? Yes, here you can see sodium hydroxide, few drops of the phenolphthalein. Then this is using hydrochloric acid. Up to some extent neutralized, and this is fully neutralized. So what will happen? Sodium hydroxide will react with hydrochloric acid and sodium chloride. Salt and water will be created. Okay, I think we are done with that. Right. Please complete the activities in the book. Right. Here actually they have shown the black zone, right? This is not really the blue zone, so you can easily identify these zones. Right. Then please complete these activities by next day. and send me a WhatsApp message, right, to the WhatsApp after completing that. So we'll be moving to the new chapter. In the book 2 next week, right? For the I'll stop from here.
Okay, sir. Thank you, sir. Good night, sir.